We've all been through some trials of late. Politics seems to be going through a phase of greater polarisation and more extremism in many parts of the world. We've had a rise in disinformation and people denying facts of all kinds. And much of this is laid at the door of software and the culture that we've built with it. But I want to look at this from a different angle today. What can we do with software to help? Specifically, how can software help us to save the world from climate change? Here are 5 ways that software can help to make a difference. Hi, I'm Dave Farley of Continuous Delivery. Welcome to my channel, and if you haven't been here before, please do hit subscribe, and if you enjoy the content today, hit like as well. Join our software engineering community by signing up for our email list or by supporting this channel via Patreon. In both cases, you'll be helping us to grow our services and get access to lots of our content that isn't available anywhere else. Links are in the description below for both of these. Today's topic is a huge one, and I won't be even scratching the surface of it here. Let me briefly touch on the idea of climate change denial. There is a close to universal agreement amongst scientists of all kinds that man-made climate change is happening now, and that this is a potential existential threat for at least our civilization, if not our species. The head of the UN, not usually an organisation that's prone to hyperbole, recently said, "We need all hands on deck for faster, bolder climate action. A window of opportunity remains open, but only a narrow shaft of light remains. We're getting dangerously close to the point of no return. The global climate fight will be won or lost in this crucial decade, on our watch. We're in the fight of our lives and we're losing. Humanity has a choice: cooperate or perish." I don't disagree with any of these things. If you do, then it is my belief that you've been seriously misled. But I don't intend to try to change your mind. Today, I want to talk about how software can help us to do a better job. And if, as the famous joke says, if that means that we accidentally made the world a better place for the wrong reasons, then I'm cool with that. So how can software do its part in averting this threat? There are lots of ways, but here are 5 big ones. To make better decisions about energy in future, we need better information. This is true at fine-grained detail level, like smart meters in our homes that help us to make better informed decisions on our personal energy usage, and at the bigger scale where energy suppliers need to make better informed decisions to optimise supply to more efficiently match demand. We also need a better understanding of the overall carbon footprint of the choices that we make, so that we can make choices that are less damaging to the climate, or at least understand the trade-offs when we can't. This is a job for software too. This is not just about energy supply, it's about economics too. How do we include the real costs of our choices in how we calculate value? How do we collect the inputs that even begin to allow us to make better informed decisions? Even at the level of including the carbon costs in our pricing, perhaps. We're going to need better ways of monitoring. Whatever the future, it's going to be more complex if it's to be more sustainable. There's a detailed report on suggestions for how software can be used to achieve the goals of net zero from the British Royal Society. There's a link to that in the description below, and I'll recommend it if you're interested in learning more. It's lots of recommendations, a bit dry, but there's lots of stuff there. But amongst them, it says this: the net zero transition should be data-led, with governance arrangements in place that enable the safe and rapid use of that data to support the achievement of the net zero target. Software then is essential in helping us to gain the insights that we need to make sensible decisions. We need to think about how to monitor all sorts of systems and start to think more holistically about what to measure and how. This is true across the board, but for example, in software alone, we tend to think of software as being fairly abstract, and it is, but it also has a direct cost in energy terms. And so, currently, each line of code that we write has a carbon footprint. And this is sometimes overblown in the media, but it's still true. We'll talk more about that later on. The importance of monitoring crosses over into the next way that software can help on my list: optimizing energy production and distribution. Whatever the future of energy supply looks like, it's almost certainly going to be more distributed and so more complicated. We're already starting to depend more and more on renewable energy sources, which is good. All of these are only intermittently available so far though. Sometimes the sun just doesn't shine in the right places, and sometimes the wind doesn't blow. So we need to manage that. To do that, we need to be able to monitor energy supply and usage more closely and make it more adaptable. This has always been a problem, but one of the directions that things are taking is to make the generation of energy more distributed. Solar panels on your roof adding electrons so that your neighbours are consuming perhaps, and soon the battery in your car being used as a buffer to keep your house working when the sun doesn't shine. But also probably doing that more broadly too. Maybe your electric car can add some of the energy that it stored away when energy was available and cheap back into the grid when energy is more scarce or in greater demand. Doubters often worry about the capacity of the electricity grid to keep up with the demand from electric cars, but energy suppliers see this as a fantastic opportunity to use energy more efficiently, smoothing out the peaks and troughs of supply and demand, using the batteries in our cars as buffers. There's already a massive untapped storage capacity in the batteries of electric cars out there that the grid could use given the right technology and software to manage it all. Another interesting way in which software is already helping, and can probably do a lot more, is in democratising or distributing the change. Here in the UK there's a fascinating company called Ripple, who effectively crowdfund renewable energy generation. You can buy a share in a wind farm and soon solar arrays. They've done deals with energy companies and you'll get your investment back in the form of much cheaper energy. So you help to build renewable capacity and get cheaper energy bills. And unlike installing your own private power generation, you can take your cheap energy with you when you move house and have access to it even if you're renting. This seems like a very internet-style solution to me. And there are others. There are EV charging sharing schemes, a kind of Airbnb for EV chargers. Software can provide us with ways to access and organise large, otherwise disparate groups of people that would otherwise be completely impossible. So changes can happen now without waiting for slower to respond institutions to catch up to the reality. There is a lot of innovation that's going on in this space and we need it. Reducing travel is another obvious way in which we can help to reduce carbon emissions. Travel is a big contributor to our carbon output and it's hard to fix. We're still a long way from being able to power aeroplanes, for example, other than burning things for long distance travel. Lots of research is going on, but the energy density of petrochemicals is hard to beat. Cars have been improving in efficiency for years, and electric cars are past the tipping point really of being practical. But even so, when COVID forced us all to stay home, carbon emissions were significantly reduced. Most of us now have easy access to fantastic communications tools. Tools like Zoom, Teams, Google Hangouts or Slack or Discord, or even for us developers things like Git, all allow us to work remotely much more easily than ever before. A report published in the science journal Nature says that the daily CO2 emissions were reduced by 17% during the lockdown periods caused by COVID globally. That's a pretty substantial gain just from people working at home, rather than using surface transport for commuting. This was wholly facilitated by software and easy access to the cheap hardware on which it runs. Making these tools better and improving the experience of working from home can access some big wins. My impression is that in some ways, despite the obviously tragic impact, COVID helped us to open the door to more widespread adoption and acceptance of people working from home. I hope that companies don't blindly return to the old ways of doing things and turn away from this otherwise useful opportunity to do things differently. Assuming that our goal isn't to make life worse on average, if you crunch the numbers on how much energy a modern high-tech lifestyle consumes, it's pretty scary. If you then extrapolate that to include poorer people in the world so that they can also take part in lifestyles like this, then it's hard to see how renewable energy production is ever going to be enough. We're going to need other sources. We're going to need nuclear energy. The real answer is on the horizon, and the joke is that it's always been on the horizon. We need fusion power. For my whole life, people have said that fusion energy is 20 years away, and always will be. The difference now is that some people are saying it's only 10 or maybe 15 years away. That may not be a big change, but something's changed. What was that? Well, lots of things actually, but one of the big changes is in software. Fusion is how stars work. Physics tells us that fusion power generation is the most efficient approach, but in effect, it means being able to contain and control a mini star here on Earth and extract energy from it. This takes the form of superheated plasma, which is a form of matter that is dynamic, very, very, very hot and fluid. Stars work and contain this otherwise rather antisocial matter by being very dense and having a big gravitational field which holds everything together. We can't do that on Earth. So we need to find ways to contain the plasma. In recent years, lots of startups have sprung up in the fusion power space, which is interesting. Commercial organisations that believe that the problems of fusion are now approaching the point of being soluble. They're queuing up to take the risk because whoever gets the fare first is going to be very, very rich. Oil company rich, only richer. Part of the reason for this new optimism is in techniques for controlling the plasma. It's not the only reason, but this alone has been an incredibly difficult engineering problem. Now this is starting to look soluble using AI. We can teach an AI to monitor and control the magnetic bottle that we keep the plasma in. And there have been some massive improvements in recent years on the sustainability and yield of prototype fusion power generators. Very big steps have been made. These would simply not be possible without advances in computing and software and AI in particular. The last of my 5 ways in which software may help us to save the planet, though, is the software itself. There's been a lot of talk about the carbon cost of software. It's been overhyped by the media and, to be honest, by me in the past. I spent several years quoting data that I'm now fairly sure was wrong about the percentage of global carbon output generated by powering data centres. I was repeating something that I'd read in what I thought was a reputable journal. Most of the figures now, though, put this figure somewhere in the region of 1% of global carbon emissions, which had come from generating energy to support data centres. That's less than I used to think, but it's still a considerable contribution. I think global shipping is about 2.5% of carbon emissions, so this is a big deal. There's good news here, though. Using software techniques, including AI again, to optimise data centre energy use, compute and storage capacity have increased dramatically, but at the same time energy consumption has not gone up linearly with this increase. It has increased a little bit to cope with that extra demand, but nevertheless not linearly in terms of consumption. Our data centres are becoming a lot more efficient, about 6 times more efficient between the years 2010 and 2018. Other good news here is that the big players who operate data centres are increasingly turning to the use of zero carbon energy sources to power their data centres where they can. There's some talk of doing things more dynamically, allocating load on cloud-based systems in particular to data centres that are currently consuming energy from renewable sources, so that you can imagine computational load being shifted around the planet, chasing the sun and the wind, as a way of maximising the use of sustainable energy. If we are to achieve net zero in time to avoid the worst excesses of climate change, then we'll need to start thinking about the carbon footprint of our software too, and taking that into consideration in all of its aspects. As the Royal Society paper puts it, digital technologies developed and deployed in pursuit of net zero must be energy proportionate, i.e. they must bring the environmental or societal benefits that outweigh their own emissions. There is certainly a lot that infrastructure providers, cloud infrastructure providers in particular, can do, and they're doing some of those things already. Hardware too gets more energy efficient. It is at least arguable that the move by Apple to use its own chips based on the much more efficient ARM technology has helped further raise the question of energy efficiency in our computer hardware. This is already an issue for data center operators, and the industry is responding by taking energy efficiency much more seriously than it once did. But there's still more that we can and must do. In a report by Deloitte, they say the technology industry is increasingly driven by the growth of software, with hardware devices taking a back seat. This is undoubtedly true. Hardware has been commoditized really for some time now, and is rarely the differentiator in market or design terms that it once was. Operating systems and software infrastructure these days abstract the platforms that support our software away from us to the degree that we don't really care about that stuff much anymore. I can run software on my Mac that was compiled for a different CPU architecture and not really notice the difference in performance. I don't really care which CPU architecture the version of Linux that I'm running in production is running on, unless I'm doing something pretty avant-garde, that is. This doesn't absolve me of all responsibility for the energy consumption of my software though. Part of my background is in building seriously high performance systems, where we did consider some of this underlying detail. Systems like these are many orders of magnitude faster than most. My experience has been that if you first make some relatively simple changes to the design of your code, you can pretty simply gain something close to an order of magnitude in performance for most systems. I can point you at some slightly trickier things to get you another order of magnitude. And I can point you at some people who, for most normal systems, can easily find you another order of magnitude or two on top of that. So we're talking about 1,000 to 10,000 times more efficient software here. It is more complex than this, but let's stick with the simple stuff. You can often get to the low-hanging fruit of a 10x improvement by making sure that you do things like pick sensible data structures. Don't pick a list when you need a map. Don't pick a map when you need a set, and so on. This usually matters because of the efficiency of finding things. If you have a list with thousands of items in it, an order 1 collection will probably be better suited than an order n collection like a list. One of my friends, who is a world-class expert on high-performance systems, sometimes plays a game with his clients. Find the business logic in the performance profile. And usually they can't, because your system is spending so much time doing whole loads of other things that your business logic performance disappears in the noise. Usually the stuff that it's doing is logging. So making logging efficient, and you can probably get a 10x improvement right there, probably more. My point here isn't to describe the techniques of improving performance, but let's stop and think about this for a second. If we could relatively easily improve the performance of our code by a factor of 10, then we could run it on 10 times fewer computers. Then, instead of 1% of carbon emissions, that would be 0.1%. That means that our operating costs and infrastructure costs, however we host our systems, are lower too. And we give the data center providers an easier job of trying to eliminate that last 0.1%. We need to start taking the carbon footprint of our code into consideration. This is almost certainly an unpopular thing to say, but that probably means questioning some basic assumptions. much as I like it as a programming language, is Python really the best choice if it's 10 or 100 times slower than alternatives and occasionally uses 1,000 times more CPU cycles to do the same thing as a language like Java? Obviously, there are lots of other considerations about things like language choice or the detail of design in your system, but should carbon footprint be one? As a side effect of my background as a programmer of fast systems, I see the massive unprecedented inefficiencies that we accept as normal in software, perhaps a bit more starkly than other people. I recognise that this is adding yet another layer of complexity onto an already difficult job. But the difference between what modern hardware is capable of and how efficiently we take advantage of that is really quite staggering. I don't think that there's any other field of human endeavour that even approaches the level of inefficiency that we accept as normal in software. This is another thing that we can and all should start thinking about to help software to save the planet. Thanks again.